Hello students. Today we are learning a very important physics chapter, force and pressure. In this session, you will understand types of motion, turning effect of force, torque, pressure and its formula, pressure in daily life, liquids and gases exert pressure, atmospheric pressure and amazing experiments. I will ask you questions in between. Think first, then listen to the answer. Let's begin.
What do the motion of a compact disc, CD, a Ferris wheel, a circular saw blade, and a ceiling fan have in common? None of these can be represented adequately as a moving point. Each involves a body that rotates about an axis that is stationary in some inertial frame of reference. Rotation occurs at all scales, from the motion of electrons and atoms to the motion of entire galaxies. It is always a good idea to keep your equilibrium, but it is more important in some situations than in others. Looking at a photograph like the one on the title page, your first reaction is probably to wonder how these acrobats keep from falling. Presumably, the poles must help, but in what way? If you think about the picture and about what you have already learned, a less obvious but in some ways more interesting question may come to mind. Why do we think they are in danger in the first place? After all, the wire is strong enough to support their weight. We might say they are in equilibrium. Should the performers start to fall, which hopefully they won't, there would initially be a sideways rotation about the wire. To avoid this calamity, another condition must be met, rotational equilibrium, which we will discuss in this chapter. These tightrope riders are striving to elude rotational motion. But rotational motion is very important in physics because rotating objects are all around us. Wheels on vehicles, as on the bicycles in the photo, gears and pulleys in machinery, planets in our solar system, and even many bones in the human body. Can you think of a few bones that rotate in sockets? 3.1. Translational and rotational motion. Motion can be classified into different types. Out of these, two are 1. Translational motion, 2. Rotational motion. 1. Translational motion. Definition. A translational motion is one which takes place along a straight line. When we push or pull an object, if it is free to move, it moves in the direction of the applied force. This type of motion in which the whole body gets displaced is called translational motion. Explanation. In translational motion, all points of the body move the same distance in the same direction in a given interval of time. There is no rotation of the body about any axis. Examples: a book sliding on a table, a car moving on a straight road, a stone falling vertically downward. 2. Rotational motion. Definition. A rotational motion is one which takes place about a fixed axis. When we pedal a bicycle resting on its stand, the crank and the wheel rotate. This is an example of rotational motion. The force applied on the pedal has a turning effect on the wheel. Such forces are analogous to forces in translational motion, but do not produce translational motion. Such forces are called turning forces. The body rotates because of the torque it experiences due to these turning forces. Explanation. In rotational motion, different points of the body move in circular paths around a fixed axis. The distance traveled by each point depends on its distance from the axis of rotation. Examples: ceiling fan, bicycle wheel, Ferris wheel, Earth rotating about its axis. 3.2. Moment of a force, torque. The turning effect of a force is measured in terms of a physical quantity called torque. Definition. The turning effect of a force is called torque, or moment of force. It is defined as the product of the magnitude of the force, F, and the perpendicular distance of the axis from the line of action of the force. Torque is also termed as the moment of force or moment of couple. It is represented by the Greek alphabet tau or TO. Mathematical expression. Torque equals force times perpendicular distance from the axis of rotation. Explanation in simple words. Translational motion means straight-line movement of a body. Rotational motion means spinning of a body around a fixed axis. Torque tells us how effectively a force can rotate an object. Greater the force or the perpendicular distance, greater is the torque. Important question answers. Question 1. What is translational motion? Answer. Translational motion is the motion in which a body moves along a straight line and all its parts move the same distance in the same direction. Question 2. Define rotational motion with one example. Answer. Rotational motion is the motion of a body about a fixed axis. Example, rotation of a ceiling fan. Question 3. What is torque? Answer. Torque is the turning effect of a force about an axis. It is equal to the product of the force and the perpendicular distance of the line of action of the force from the axis of rotation. Question 4. Why does a door open easily when pushed near the handle? Answer. Because the perpendicular distance from the hinge, or axis of rotation, is maximum near the handle, producing greater torque. Question 5. Give 2 examples each of translational and rotational motion. Answer. Translational motion, moving car on a straight road, falling stone. Rotational motion, bicycle wheel, ceiling fan.